Hi, my name is Sheila Hobson.
Hello, I'm Kathy Foy. We love robots, and we would like you to be part of our team.
Kathy and I are the course designers, and we teach 5 of the STEM courses here in the Masters of STEM Education program.
So STEM stands for science, technology, engineering, math. But we like to expand it just a little bit to include entrepreneurship and art, since everyone has something a talent that they can use.
That's right, Kathy. So we design these STEM's hands-on classes to help our students learn the mindset of learning by doing. In fact, here is a VEX robot that they learn to build and program, and here is the brand new Spike Prime robot. Today, we're going to talk about why STEM education is so important and how the engineering design process helps us solve a real-world problem. And using this engineering design process starts off with a goal. And how do we accomplish a task or find a product that will help mankind? Kathy, would you elaborate how NASA uses this?
Well, the design that they use, the diagram that they use, has the goal in the middle. And then you begin by asking the question. And then, you have to imagine what it's going to look like. And this is where you get ideas from other people. And then actually sit down and plan it out. Follow through by creating the plan, experimenting, and improving. So I believe we rise to the challenge of making a better world. We have to remember this process of creating new ideas, and it requires iteration, 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 improvement all the time. Once that's finished, you have to market and share it with the rest of the world. This engineering design process is the foundation for any invention, and that's what moves mankind forward. So sometimes the biggest hurdle is just coming up with ideas.
That's absolutely true. And our students learn that it's important to always start with a need and something that they're passionate about. This process always helps promote higher level thinking, like analyzing, synthesizing, critical thinking, collaboration, and let's not forget communication skills. The United Nations is certainly committed to making a better world.
So we love to challenge our students to find a real world problem that needs to be handled. They want to make a better place to live. So they're going to learn skills in our STEM education classes, how to build, the basics in sensors and programming, testing and marketing. And they're going to be working with these models. So you have to start with an idea. And we like to say that your passion ignites your action.
Absolutely, that's exactly right, Kathy. Our students learn to take this engineering design process and learn to use it the same way the professional engineers do. Every day we benefit from all the new innovations and products that have been produced. For example, our cell phones and satellites and GPSs. And it's amazing all the new things we're using.
So you might see a robot in action walking down the grocery store. Marty is a robot that actually takes inventory or simply cleans up an area to make it safe for people to walk down the aisle. But somebody had to create that robot. They had to program it. They had to maintain it. At Webster, we're very dedicated to developing this mindset. So, for example, in one of our classes, we have 3 different smart tools. This is a microchip, and you can do a number of activities with it. But in this case, it's like a Rube Goldberg, because the programming allows you to code the microchip, which then will send a message to the drone, which then will send a message to the Sphero Robot. I remember Grant, who coded all of these.
Yes, I'd love to share his story. He did. He took the microchip, put it on the hiker, and when he programmed the drone and the Sphero to interact, to find and rescue any lost hikers. How about Joanna? She came up with a water filter that also helped learn how to produce clean water for the world. And didn't she build a 3D model with that?
Well, she was just so inquisitive, and she had dedicated herself to making this. So she started with drawings, and then she put them on CAD, and then she worked with the Tinkercad, took that code and put it into the 3D printer and actually made some parts. And she wasn't totally excited about this, so she iterated, she improved it, and she was constant. And how do we know that? Because she actually documented it with video and put it in her engineering design notebook.
That's right. What about Ashley? She designed an autonomous robot similar to our VEX that learned to put out forest fires.
Yeah, and a smaller version would have been that they could have used in the laboratory as a model, like our Lego Spike Prime. I have a sister who lives in Lake Tahoe, and she had to evacuate last summer because of the fires. And I have a nephew who's also a member of CAL FIRE, he's a captain. It would certainly be nice to have that robot in action today for them. Here at Webster, students learn the basics. They have the tools, the models. They discover how to program. They iterate, they improve, and they are creating and then sharing and marketing their ideas with the rest of the world. So remember, your project starts with your passion, which then becomes action.
As you can see, Kathy and I are very excited about the engineering design process and developing new ideas. We invite you to join us at Webster University and earn your master's in STEM education and be a part of a team creating solutions through STEM innovation.